We are back with lesson topic 5.2 properties of exponent and radicals. And mine's filled out. Yours is not filled out. We're going to deal with this a little bit more tomorrow because I thought today we would spend our entire time talking about first, because I don't remember how much of this you had in Algebra 1, how we add and subtract radicals or rational exponents. Okay, so the way that we do this is we are going to make sure, in order to do this, that we have like terms. And like terms, when we're dealing with radicals, is that they have to have the same index. The index is the type of root it is. And for our purposes today, we're only going to deal with cubed roots or square roots. And they have to have the same radicand. And the radicand means the thing that's inside the square root has to be absolutely identical and in order for us to put them together. So the radical portion has to be exactly the same. So now, before I do that, what I realized here is maybe we should back up a little bit. So we're going to do some of these examples in a second. But let's back up and look at just some numbers, okay? So suppose I asked you to simplify. And I said we have 11 times the square root of 7, take away 4 times the square root of 7. So what we need to decide is, first of all, is the index the same? So these are both square roots, so good. Also, is what's inside the square root exactly identical? They are. And so we almost treat this like when we have a variable. As long as these two are exactly identical, we can put them together. I have 11 root 7 and take away 4 root 7. Putting that together, this simplifies to be 11 minus 4, which is 7 root 7. Okay, let's try another one. Suppose I had 5 root 3, take away 3 root 2. So I'm going and I'm looking, and I notice square roots are the same, great. But underneath the radical symbol, this is the square root of 3. This is the square root of 2. Are those two exactly the same? They are not. And so at that point, this is as simplified as we would get. You cannot put together 5 root 3 minus 3 root 2. And furthermore, you can't take any square roots out like we did yesterday. You can't take anything out to get them to be the same. So this is simplified. Okay, well, suppose I gave you the square root of 20 minus the square root of 5. And at first, we look. Square roots are the same, great. And I say, oh, 20 and 5, those are not the same. Okay, can't do it. Hold on a second. Can I rewrite 20? I can't. I can rewrite 20 as 4 times 5. This is still the square root of 5. I can take out the square root of 4. What is the square root of 4? It is 2. So I have 2 square root of 5, take away, I'm going to put a 1 square root of 5. 2 take away 1, now the radicands are the same. 2 take away 1 is 1 root 5, or you could just write root 5. Okay, let's do one more similar to that. So suppose I asked you to simplify the square root of 98 minus 3 root 2. So, and it might be helpful too if you want, remember, if you're wondering how to break down these, is to take out the root cards you got last week. The square roots are all in this column right here, okay? And so we're looking for These are not the same radicand, but we're looking to see, can I maybe rewrite the square root of 98? Is there anything on my list, the highest thing that goes in? And I see 49. So I'm going to rewrite the square root of 98 as 49 times what? 49 times 2 minus 3 root 2. I'm then going to take out the square root of 49, which gives me a 7. So I have 7 root 2, take away 3 root 2. At this time, I have the radicands, square root of 2, square root of 2. The radicals are exactly the same form. 7 take away 3 would be 4 times the square root of 2. Okay. And so today, at first, you're going to see some things that just involve numbers. Be aware, I did put a couple cubed roots on there. So cubed roots, we'd be looking in this column. Okay. All right. Now, what does that look like when we have some variables in the mix? Okay. So we'll do a couple of these as well. When we have some variables in the mix, I look here and I am going to try to simplify if possible, and then put my things together. So like from yesterday, I cannot take a 3 out, but I can take a out. So a comes out, and I can rewrite this. Remember b cubed, a squared. B cubed can be written as b to the second times b. I can also take that b out. So I have an ab, and then 3b stays in. I maybe should have rewritten that a little better. I'll rewrite this one. On this one, I'm going to rewrite 12 as 4 times 3 because 12 has a perfect square that goes in it. I am going to be able to take out the a squared, and I'm going to rewrite this as b squared times b. So I am going to be able to take a 4, an a squared, and a b squared out. So from over here, I had ab times root 3b. Take away, now over here, I have 2ab, and underneath is the square root of 3b. I know this is a step up. We can do it. So I take I have 1ab minus 2ab. That gives me negative 1ab, and I put them under that like radical now because that's exactly the same, which is 3b. Okay. Okay, we're going to do a couple more of these. Let's rewrite these as radicals. So this would come out to 2x times the cubed root of y minus 7x times the cubed root of y. That's a cubed root right there. Because x to the 1/3 and y to the 1/3 are cubed roots. The radicands are both the cubed root, and underneath here are both y's. That means I can put these together. Are these like terms? They sure are. I have 2x, take away 7x. That would be negative 5x times the cubed root of y. Okay, let's keep going. I look over here, I can't simplify that at all. I'm guessing I can simplify this. So I'm going to rewrite 8 as 4 times 2. X squared is already even power. And I'm going to rewrite y to the 5th as y to the 4th times y. I take out any perfect squares. So the square root of 4 is 2. The square root of x squared is x. The square root of y to the 4th is y squared. Underneath the radical, I have the square root of 2y. Over here, I have minus xy squared times the square root of 2y. I check on my radicands. They are exactly identical. They're both square roots, and underneath are the expression 2y. So I take these, and I'm like, hey, those are like terms, xy squared and xy squared. We have 2 take away 1, this would give me 1 xy squared times the square root of 2y. Okay. Let's try one of these. I have 5 2x to the 5th. So I'm going to rewrite that as 5 stays there. I'm going to rewrite x to the 5th as 2x to the 4th times x. Okay. Over here, I have an x on the outside. I am going to rewrite 18 as 9 times 2 x squared times x. I'm going to simplify any square roots that I can. I have an x to the 4th here, and I have an x squared and a 9 here. The x to the 4th comes out, and the square root of x to the 4th is x squared, so we have 5x squared on the outside, the square root of 2x on the inside. Next, on this side, the square root of 9, so that x is already there, the square root of 9 is going to be here. There's already an x. The square root of x squared is also x again. That's going to give me x times x, or x squared. Okay, so then we have 5x squared times the square root of 2x. Now, do you notice, hopefully, on all of these, what's happened is you've gotten to a point where the radicands are the same. So I have 5x squared, take away 3x squared. This gives me 2x squared times the square root of 2x. Okay, so that's where I'm going to stop for today. I did not put any questions like these last two on your homework, so we're going to stop with that. I think that's definitely, I think, most of you are going to pick this up. This is definitely a challenge. You might have to ask some questions on this portion, but now I have some for you to try on your own.